to take the first section this morning. I will pass it once again to Mohammed Nazer, and he's going to handle part one of consuming bare metal.
Thanks, Jonathan. Good morning again, everyone, or I guess in some parts of the world also good evening, and I don't want to say good night. I'd say that's pretty late to say that. First of all, yeah, we have an Etherpad going just like we had yesterday, so I'd like to invite everybody who'd like to be part of taking notes to open that up and throw your name in there if you're participating. It's really helpful to know who will be there, and make sure to leave an asterisk if you're looking to participate. Our first topic that we came up with today is hyperconverged. And I guess one of the nice questions that was added this morning was really, what do we define hyperconverged as? I think there's different various definitions of what hyperconverged is. And inside our realm of the industry, hyperconverged implies that you have storage and compute resources on the same machines. That's what I think when I think hyperconverged, but I'd be happy to hear on some other ideas of what other users consider hyperconverged to be.
I kind of view it as both storage and compute and all of your networking in kind of like a little isolated island that can operate as highly efficiently as possible. Is that a word? But I feel like when I put the question on the Etherpad, I was like, well, let's make sure people are using the same words. So it's really important, I think, for people to kind of convey what they think, even if it's just agreement.
Yeah. So it's really interesting. We have a comment from James in the chat saying that for them, it includes controller as well. And for us, it doesn't, for example. So are there any other users that also feel like it includes controller in that equation?
Yeah, this is Beth. Let me also bark in. I think hyperconverged came out of the grid computing community. So a lot of the terminology and what it encompasses comes out of that thinking. So in that case, it's kind of a all-encompass. It has everything in it, which it does include the controllers.
Mm-hmm. Okay. That's interesting. So then on that note, I've found it pretty difficult to already get storage and compute interacting without intervening too much with each other. Has anyone kind of added the control plane to the equation, and how do you make sure that things don't start, slowing down each other, or specific services start eating up a lot of resources?
And are there specific architectural decisions, or is there software settings, or is it application layout?
Yeah. I noticed some of the people in the chat are talking about their use cases. I'd be really happy to hear you, maybe if it's possible to get on voice and talk a little bit about the use case, especially I think Jaden's talking about carefully tune and reserve memory and resource allocations. That's really interesting.
Hi, so this is Jaden. So we're using OpenStack and Ceph for cloud and for compute and storage. And so OpenStack, we use the compute settings for reserving resources for the operating system. And Ceph has similar settings too, where you can reserve fixed amounts of CPU, threads, and RAM for other uses. So that's what we do to achieve this kind of super converged infrastructure where we can run the control services and the compute and the storage all on the same hardware, with the understanding that this is a small scale kind of, maybe you wouldn't want to run like your big operation on this kind of setup. This is more for like a development kind of cluster, or a testing kind of cluster, or a small scale production cluster.
So So that's interesting because that really wanders into the edge use case, which is what the comment I put in to the Etherpad. Because if you think about edge is a form of hyperconverged, right? Because if it's, if it's one rack or a single box, it still has to have everything incorporated in it. But I don't consider edge particularly to be hyperconverged. Or maybe that's just my thinking.
I can maybe like contribute our use cases as well. So this is Arne from CERN. We have like basically like two use cases that we would call hyperconverged. So we at CERN we run our own like massive storage system that was developed in-house. It's like 250 petabytes raw capacity. It's thousands of servers. However, the servers that we buy are usually not bought specifically for the storage system, at least the head nodes. They're usually bought for the batch use case. But then all the CPU and all the RAM, so we basically buy the same hardware for all use cases, more or less, to not have like too many different. So one idea that we had years ago was to like make use of these CPUs that are on the storage servers. So we put some of our batch capacity there, and then we like this went into containers to like basically seal it off from not disturb the storage system. So this is basically, so one use case is to basically make use or efficient use of the resources that we have and use every cycle that we have. So that's one use case. The other use case we have is like similar to what Jane just described, which is a cell in OpenStack where we combine Ceph and use the storage that's on the hypervisors in order to have a Ceph cluster or service cluster in the same cell. And the use case here is not so much, it's also like efficient use case, but efficient use of the resources, but here it's more to achieve low latency. So this is specifically for VMs that then run the cell that need low latency access to the data. So we have one setup for HPC, for instance, and for some other application like Kafka queues, which need to like, for instance, have very quick access to the storage. So this is kind of the two use cases that we have. So it's like efficient use of resources or like putting everything closely together to reduce latency.
So I think just an interesting question that I want to throw back at Jaden, and I don't know if maybe this is something that makes sense for you or not, but one of the things that I've seen in hyperconverged deployments is it's hard to grow, while it starts easy in theory to grow one aspect like storage or compute, eventually you reach a point where it doesn't make sense to linearly continue to grow storage only. Sorry, both storage and compute every time you add a new node to that hyperconverged cluster. And so if you start adding storage, you start eating up into the memory that was previously allocated for computes, and you kind of have this weird off balance. Have you kind of thought about something like that, or have your setups mostly been a single node thing?
So we start with a 3-node setup, and for our when we want to scale, we just add additional hardware units. So we use small hardware units for our for these little clouds. Like we'll start with 3 that are running in a control plane compute and storage setup, and then as we want to scale those and scale CPU or storage resources, we'll add additional hardware nodes that are configured to provide either just dedicated CPU or dedicated storage. One of the things that helps us is that these clouds are small enough that the control plane services don't get too taxed. I think it's something that Slavash in the chat box mentioned, is that because I know for a big cloud, you're going to run a lot of resource usage on your control plane, and it's going to be busy and really active. But since these are relatively small clouds, they're only going to run at most a couple hundred VMs. That it's not too bad. But again, like we understand that this isn't, you wouldn't want to run your big Hadoop cluster or some kind of big data crunching or processing kind of use case on this. You want to get something more powerful. Or something with more of a dedicated control plane or something like that. But that's how we scale, is that we just add additional hardware units that either provide compute and storage, or just compute or just storage, and attach them to the existing Ceph cluster or the existing OpenStack cluster.
But then operationally, do you kind of have issues with like this quote unquote unicorn compute nodes that are like not really a compute node, have other things? We have different profiles of systems.
We haven't run into too many problems with that yet, but that's something that we'll have to run into. So you mean like when you're allocating VMs?
Well, like let's just say you want to run a maintenance, and you're like, okay, well, if I do a maintenance on these subset of machines, that's a lot more straightforward than this other subset of machine, because this one only has VMs, and that's easy to deal with. But this one also has the control plane running on it.
Oh yes, I understand what you're saying. I will say haven't been running these kinds of clouds in operation too long yet. So that's something that we'll have to address. I think I know we've been trying to plan for like updates and those kinds of things. We use Kala and Kala Ansible, and that's been those projects have been helpful. They use containerized Docker container, like they use Docker containers and containerized OpenStack services to make it easier to do deployments and upgrades. And in our experience in running a larger cluster using those things, it's been fine so far. But I think what we're planning on doing, I don't know. We don't actually have I don't think we have a plan for that yet, because that's not a problem that we've quite gotten to.
This is what we're here to discuss and learn.
Yes, I mean one of the things that we have on our roadmap is like, what do we do from when we have a release for OpenStack that we have to do, and we have to do like a jump from Train to Usuri or something like that, or Usuri to Victoria. Like, well, how are we going to manage that, especially if we have multiple? If we've got 10 or 20 of these little clouds set up, how are we going to manage that and coordinate that?
Jaden, that's actually a very tough question, and unfortunately, there are companies that have gotten stuck at various points for exactly that reason. So yeah.
I'm sorry, you can finish.
Okay, I was just going to say, you have to really think about if you have the capacity to do like a rolling upgrade.
Yeah, I would say I think we so in our upgrade process experience with Kala, rolling upgrades seem like it's been pretty good, and then you can do upgrades of a lot of control plane services and core services without disrupting your virtual machines. That's fortunately, I think, a testament to how well OpenStack has things orchestrated in that regard. I will say one of the advantages to our small cloud strategy is that a user could just make we could just make another small cloud and mirror over the data onto the new release and test it out and have it be ready to go and validated. And then we just discard the old cloud or recycle the hardware and update it after it's no longer in use. That we have the advantage of not having 1,000 node deployment or some huge deployment that we have to worry about managing them. We can just make a new small cloud and migrate to that to move forward.
So I can chime in here as well. This is James. Jaden's setup seems extremely similar to mine, actually. And I don't know if you work for a university or not, but I do, and maybe that's why. So we have primarily a lot of older equipment, 11th generation Dells, and we've got about 6 racks of servers, but each rack is its own deployment. So we have maybe anywhere between 10 to 15 servers doing its own thing. So we also use Kola, OpenStack Kola, for Dockerized containers. And we do hyperconverged. When we bring down a control node, because we do HA, we're very careful, but it doesn't seem to impact anything because you've got the other 2 controllers, going. And we do an AB system where, we'll have one. We don't do we theoretically could, I suppose, do the rolling upgrades, but we prefer fresh installs. We fine tune it every time we do a fresh install. So that's been our procedure.
Well, I'm glad to hear that, James, because I think that's what we're looking forward to when it comes time to do the big releases or big updates, is that we'll just try to steer our teams and consumers of our clouds to just getting a new cloud and mirroring the Ceph data over doing their tests and validation checks so they can have that change without having any kind of disruptions to
Yeah.
their regular operations.
Yeah, yeah, and we've had some issues with and perhaps it was user, essentially my error because I'm the one who deploys the clouds. I've developed a series of tests just to smoke test our deployments as well. We use Ceph, but once Cola removed Ceph from their deployments, we stopped. Primarily because it's me who's deploying everything, and so I haven't devoted enough time to master Ceph plus OpenStack plus all the other stuff that I'm supposed to do, because that's not my primary. This isn't even my primary job. But I'm going back to yesterday's conversation and today's, I'm very excited to see how much Ironic has changed, because right now we use Mass, and I'm hoping that we can switch it over to have sort of a triple O type setup where we could have a small cloud but deploy everything else onto the other systems instead of using Mass, and that would give us our Windows systems that we need as well. So it's nice. It's nice seeing this progress.
Yeah, I will say we use Bifrost, which is standalone Ironic. We've been using that, testing that for deployments. And I see John Garbett asking about KOB. We tried KOB, but for our particular use case, it was a little too opinionated. I will say KOB though probably is a good fit for folks who want to do something like Triple O, but maybe they want to have it be a little lighter. Because we tried Triple O out as well, but found it was a little too, well, it was even more opinionated than KOB was. That it had a lot going on. We didn't want to have to run an entire OpenStack cluster to deploy other OpenStacks, and KOB seemed like it was a good fit for that. So I would certainly encourage people to look at KOB as well.
Maybe that's
you, James.
Maybe that's what we need to look at too. But it'd be good to connect with you outside of this as well.
Oh yeah, I would love that. I think we've got a lot of, it sounds like we could share a lot of expertise and experience.
Yeah,
in this
definitely.
area.
Definitely.
So the natural question might be, is there something that could be done with the bare metal SIG to help raise some of these use cases and configuration possibilities to the public?
I know for us, we tried using Ironic several times in the past, but we've, at least for us, and it might be that, like I said, the age of our equipment, but it was always rather difficult to get set up, and we'd spend days or weeks trying to get it up and running, and we just weren't able to. So we reallocate the servers so we could use them for other things. So I think always the making it as simple as possible is always a good thing. But besides that,
I'll say for our part, we're using Bifrost, but we actually started with KOB, and that KOB is really good about getting Ironic Bifrost set up for you with some good sane defaults. It gives you the tools you need to get started doing your work with your hardware. I'll say, like I said, for our individual use case, we're kind of pulling back from KOB now that we know more about how Bifrost works and how KOB works, because it's not exactly a good fit for our use case. But for us, it's certainly helped us get to the point where we can say, yes, we know how to use Ironic. We're comfortable to try to do it on our own. We're still not there yet. We're still using the KOB seed host, even though we're not using like the KOB command line stuff so much now for our usage. But I can definitely say it was great for us to go through that experience using KOB to learn the basics of hardware management and that kind of stuff. And
I know yesterday there was some conversations about how you monitor the hardware. We grew an in-house tool that probes all the IPMI diagnostics and reports back to us on a website. So we have it display essentially our racks in physical form with the U dimensions and everything like this. And if it's green, everything's running nicely. And if it's not green, it'll be red, and it'll show us the errors as well that are happening there, so we can see, you know, a RAM stick died, or a CPU is failing, or a hard drive is failing, or a hard drive failed and came back. You know, these type of weird things. And then if there's a communication error, it goes orange. So you know, that's what how we monitor our hardware remotely.
I guess James has managed to eliminate the idea of walking through data centers by replacing it with a website that you look at instead.
Yes, absolutely. So my role is to help with research. My secondary role is to do IT, and so I can't spend my full job doing IT if I've got to help with research. So I've needed to automate as much as we physically can, which is why Mass, Ironic, these type of things would be, you know, great to have working. And, you know, I've been using OpenStack for a long time, but yeah, Ironic has just been that one that I've had issues with. So, you know, we try to eliminate walking across campus as much as possible.
Yeah.
Well, if
What
there's
are
any,
your issues with Ironic? I'm sorry.
You can go ahead.
So I was just asking what your biggest hurdles were with Ironic when you were attempting to use it.
For us, I think it's our network setup that's the issue. If I'm remembering correctly, we to Pixie, and we had similar issues so we were able to Pixie it, but we weren't able to get the rest of the networking up because of how we had our setup. So we had one NIC that is air gapped, which is what we're using to Pixie it. And then our public network is another NIC that could get onto the internet and do other stuff. And I think that was our I think that was our biggest issue. It's been a long time though, so I may be missing some things.
we might have had some features recently in the past year that might help those sorts of environments, like multicast DNS and auto discovery of components running. So that might be things that help those environments. But I think if we can go back to one of the questions that was asked in chat, I think it'd probably be pretty good for us to highlight that.
Yeah. Just going back briefly to a question that was asked in chat earlier, which is asking if the meaning of hyperconverge means 3 controllers that are also compute, or spreading the services all across the compute and storage nodes. And I think this might have different answers depending on the scope. I know Jaden, maybe you can share a little bit about your answer here. And
Sure. So for my part, for our deployments, so we can have high availability, we run on each individual node, we run compute. So OpenStack Nova, we run Ceph, and we run all of the control plane services. So Neutron, Glance, Placement, Keystone, all of those different services. And we run an instance on each of the 3 nodes so that we can enjoy that high availability, so that if we do lose one node, like James said, that we can still be up, we can still have our VMs work properly and not have any disruptions for our tenant users, even though maybe they can't create new VMs or manage that way. But I mean, I hope if we have a published maintenance window and people understand the expectations, they'll know, hey, your websites are up, your applications are going to keep running, your work's going to keep happening, just don't do anything right now. Take a break, and they'll be okay.
I'd love to also hear Beth's POV from like an edge perspective. Is that the same definition, or?
Yeah, I've been thinking about this because edge is, Edge has the additional constraint of the edges far away, right? And not necessarily, you risk, it has to stand alone, right? So by its very nature, it has to be hyperconverged. So I think that, and again, I think the hyperconverged question kind of bifurcates at this point, that
Yeah.
edge is a flavor of hyperconverged, but I think since hyperconverged came out of the grid architecture model, we tend to think of it as massive. But edge is, of course, not massive by its very nature. So I guess I'm
Right.
blabbing here. Hopefully you got figured out what I just said.
So I guess it feels to me like while we're talking about hyperconverged and like constrained environments, I guess in an edge scenario, it's not necessarily, we're talking about a constraint of one rack, and that's probably like that's a small constraint in the context of an edge deployment, but it's probably a larger one for someone who's trying to have a small deployment for their their small business or something like that.
Well, one rack is I mean, for many edge, that's big.
Oh, okay.
Yeah, I mean, the telco edge tends to be in a a small number of racks, but in my world, edge is one or two boxes, and there's a lot of scenarios out there where where people are looking for one or two boxes. I mean, a retail environment, for example, they want to minimize the footprint down to as little as possible.
This is Jane again. I used to work in hospitality, and I know it's funny to think of this as edge computing, but I guess it is. We had one server behind the front office that like powered the local property management system, and it synced to the central database.
Yep.
And that was kind of a big thing like that. I think you're right that businesses really just want one or two. They're going to have the minimum amount because they just don't know. Like it's just, they don't understand the technology, or they just want it to work.
Well, and they don't have anybody on site. I mean, retailers in particular, think the coffee shops of the world, they have a bunch of stuff that needs to be out there at the edge. They can't all run it over the cloud. And retailers are particularly sensitive to, if it's all in the cloud and they lose the ability to do credit card transactions or, take sales, that can be really expensive.
At the same time, it seems like if they're only deploying one, maybe at most two machines, it seems like that they either have built the processes and supply chain to be able to recover quickly regardless, or they just don't see the cost benefit hashing out to be 3 machines or 2 machines sometimes.
Retail runs on a really thin margin, and 2 or 3 machines for many of them they have to think about it. I'm working with one retailer. It's in the Quickie Mart business, which is, if you go into a gas station, there's that little market there. Think about those, they run on razor thin margins. They don't have room literally to put a rack of equipment.
Yeah, that's really interesting, actually. So that's
I'll say for hotels too, it's the same kind of way, that there's too tight on the margins, and the I would say the leaders don't understand the technology to really well enough to be able to understand the business value, for someone to articulate the business value to them.
Right. And if they need to have somebody on site to babysit that rack, that ain't gonna happen.
Yeah. So I think that brings another interesting point, which is when we're talking about kind of hyper-converged systems, I guess there's like 2 stages, right? Because we have hyper-converged that, I have the comfort of a rack and cooling and whatnot. I just have to have a small footprint. And then we have another use case of hyper-converged, but I also probably need somewhat of a resource-constrained server that is not overly expensive, with kind of more cheaper hardware to make it sustainable, because that small quickie mart you talked about is not going to spend $15,000 on a full system unit with fans and everything running.
Yeah, that's where we are. That's where our hyperconverged use case comes in, is that we are targeting, it's a super microblade sled that has 2 server nodes for a single hardware sled. So it's like a hyper dense, low cost kind of cloud hardware that we're using. So you have to do, if you want to run the whole cloud on three of these guys, you have to really be tightly constrained on your resource usage and how much you're giving everybody. You have to be real strict with it. And it's so that we can have low cost cloud. So we aren't having to spend $15,000 or $20,000 just to get a cloud for somebody to use to run like a little CI/CD workload or something like that.
Well, let me add to that, which is, again, going back to this quickie mart company, because I kind of pushed back at them and said, well, why don't, are you looking at the Nutanix box, or, there's a couple other boxes out there that are hyper converged. And, they basically said they're too expensive.
Yeah, that's kind of an interesting approach. So I see some discussion going on right now that started by John talking about using hyperconverged disks instead of Ceph. John, do you want to talk a little bit about that point? Maybe we can discuss that a little further, because I feel like it's an interesting discussion to have.
I can do. I guess I'm still struggling with the concept of hyperconverged a bit. Well, the definition of it, I think, is a good question. So I guess I was thinking about, if you have a hypervisor or whatever, and it's just using the local disk, does that make it a hyperconverged workload? It's kind of, in that case, you've sort of almost got no virtual storage. I suppose you've still got QCOW in the way. But,
yeah.
And sort of following on from that, I guess I was sort of saying, I was backing up the support for the KOB model, where you're kind of using Ironic to install the hypervisor. Because in a sense, I think we've been using a lot of Ironic to install storage workloads in general, whether they're like shared file systems like Lustre or BGFS or Ceph or the hypervisor itself, I guess. They're kind of in a similar frame.
Yeah.
I was just wondering if people have seen the same thing.
Yeah. I think it's an interesting question with regards to if the storage is in the same node, if that's actually hyperconverged or not. I don't know. I think when we're thinking yeah, of course, but it is storage and compute on the same machine. Is that hyperconverged?
Yeah, it says it's not off box, is it? It's not a SCSI card to some JBOD at the bottom of the rack. But
yeah, so that's an interesting question, and I don't know. I guess to me, it's always been on a lower layer of like, or is the infrastructure services, is Rabbit and is Rabbit and the Nova services and Neutron and all that stuff, is that all running on in the same machine in the same box, kind of like an all-in-one? That's hyper-converged. Whereas, like, for example, I would take the case of CERN, where they use local storage on their hypervisors, and I don't think CERN is using a hyper-converged setup. Well, at least that in my terminology, I don't think so, at least. Cool, that's really interesting. Yeah, I think it's been a pretty interesting discussion that we just had on hyperconverged. I don't know if anyone has kind of any comments to also add on any of the points that we have put on, because we also talked a little bit about, it seems like there's some comments also about hyperconverged Ceph things as well. I don't know if anyone has actually gone that far from the million warnings that are on the Ceph documentation saying not to do that. But just wondering if someone has actually went ahead and did that, and how they are doing that.
I mean, that's what we do. We run the Ceph OSDs on top of the same hardware with the Nova hypervisor and Neutron and Rabbit and all those kinds of things.
So your Ceph monitor and Ceph OSDs are running on the same nodes?
Yes.
I see.
Yeah, we have a 4-node deployment with Ceph, where that's our 3 controllers, our 4 computes, and our 4 storage. So all on 4 nodes. So yeah, it runs. We remind that one has not a whole lot of storage. I think it barely has 1 terabyte of storage between the 4 nodes. So we just remind our users that, go easy on it. But we have another, talking about hyperconverged without Ceph, we have another actually a smaller 4 node deployment. We removed the Ceph because the users were complaining about how slow it was taking to boot up some VMs. And so we did it on disk, and they were able to get their VMs up a lot faster. But it's again 4 node with 3 controllers. So those are our 2 smallest clusters that we have. The others are usually triple that size or so.
Yeah, I mean, like I said, for the key for us is that we do tell our user and expect our users, hey, this isn't a thing you want to go crazy on. This is the little cloud you use to learn the basics of OpenStack and how to do cloud native application development and processes. And then when you get ready to go big time and do production stuff, let's add some more nodes, or let's get you on this other hardware that'll better suit your needs. That this is just so you can really get into the ecosystem at a cheap price point and accessible way for us.
Mhm.
But
Thank
like,
you,
can I get
Sahar.
back to? Sorry.
Yeah, go ahead.
So in our case, just to be clear, like in the Sun's case, it's really like we have a set of hypervisors, several 10 of hypervisors, and they run Ceph on the very same node. So it's like they are basically running Nova and Ceph on the same nodes, accessing the local drives for I/O, and then we have VMs hosted on these hypervisors. So it's all in this set of machines for the low latency access. So, and then we make sure that like, okay, it took us some time to figure out how to like protect services from each other, so that if you like put on VMs, they don't like affect the Ceph service, because then they could be booted, for instance, from volumes that are on the same in the same cell, right?
Yeah. So I'm curious then, for those that are running both the Ceph monitor and the Ceph OSDs on the same node, how have you dealt with upgrades, or is that something that you haven't gotten around yet? Because usually there's some recommendations around the order of upgrading, and if everything is all running on the same host and you upgrade the packages, it's very likely that you might end up in a situation where some of the packages get updated. Like you have some OSDs that are running newer versions, but the others are still running, or the other monitors are still not running a newer version. So has anyone kind of explored that idea?
For our part, we use containerized Ceph. We use Ceph Ansible to deploy our Ceph. We're going to probably switch to Ceph ADM in the new version Octopus. And Ceph ADM uses containers by default for deployment. So I know that would help protect you from updating like operating system packages underneath Ceph. And with the containers, you can just do it the way they recommend it, because the containers, as far as they know, they're separate hosts effectively.
James, have you, or sure, you can go ahead, Arnie.
So one of the things that we do is like we have like the mons in our case are VMs, right? They're not physical nodes. So this way we can also like in that cell, we can move the mons around when we do upgrades, for instance, and then have like go in stages when we upgrade. For instance, when we have to do a reboot, some of the OSDs will go away, but Ceph doesn't care too much if it's not too many. And then mons we kind of basically can shuffle around in the cell, for instance, when we need to do upgrades.
And James, have you gotten around looking at that issue, or is not something you've gotten around yet?
Yeah, for us, we haven't really done that because we usually do clean installs. So we haven't had to do any updates. I know what the last gentleman said about using VMs for the Ceph mons. We looked into that. We had a lot of performance issues with that. Surprised you're not running into that as well.
Yeah.
Well, what we do. So one of the reasons, or one of the things that we do in order to protect the services, I mean, as I said in the very beginning, when you have to, or when you run multiple services on the same host, you have to make sure that they don't like crosstalk somehow. So one of the things we do this for the first use case is like to have this batch computing in containers in C groups set up so they don't like exceed the amount of resources that they're allocated. And for VMs, for instance, we use pinning so that they have like CPUs that belong to a specific application so they don't interact either. So, but most of our like infrastructure in Ceph, and we have like, I don't know how many Ceph clusters we have, meanwhile, around 10 or so. Most of this run with like virtual machines on the control plane.
I kind of think it's also important to take a step back when we start talking about services colliding, because I/O patterns with disk controllers or storage controllers you can have very different behaviors of those devices based on the pattern size of operations that you're doing against them. So one person's load may look completely different from another person's load, and the disk may behave completely differently.
Yeah, I'll second that. I know our load is small because we're an institute. We have, I don't know, maybe 20 people on it. 100, maybe 100 to 200 VMs depending on what we're doing. But it's that's spread across maybe 15 servers or so. So it's none of our servers are ever heavily taxed. There's always tons of compute available for everything, and some of our newer servers have SSDs, but even the majority of ours just have spinning Rust. So yeah, low load usage.
Does anybody use a dashboard with HCI? Ceph dashboard?
We have the Ceph dashboard.
We use a Prometheus exporter that is now native to Ceph, where it's just like the manager, you just enable it in the manager and exports all the metrics. It works pretty nicely for us, but honestly, we've seen issues that it takes a very long time to pull when you have a lot of OSDs. So we really had to tone it down on some of the larger clusters on how often it scrapes information. But I think there was an issue around that was cleaned up. And also there was another thing that was, if you had multiple Prometheuses scraping at the same time, it held a global lock. So one of them would constantly be timed, like two, if you have three, two will be timing out while one is getting served a request. So that's kind of one of the issues that we ran into when doing that. I know that we had some individuals from China Mobile yesterday. They talked about some of their infrastructure use cases. I'm wondering if they're around and if they do anything that's hyper-converged, or maybe they can share if there's anything on the hyper-converged aspect that they do.
I have little experience about the hyper-converged systems, but I have some experience to share with you is about that. Because now we build the large cloud, so now we use the servers separated. Some are for the computing and some are for storage. For the computing, we use the computing models, and for storage, we use storage models, which is optimized for the different use. For example, the computing and storage. So I think in the large scale scenarios, we will use separated servers for different use. Another scenario is about the edge computing. I think because at the edge computing scenarios, the resources is limited. So we should use the hyper-converged models to both include both computing and storage. So I think at that scenario, it's good to use the hyper-converged models. Another thing is about the operation. As you know, it's maybe it is a pinpoint for the users when the computer is has crash or have some problems. It will have some influence on both the computing and storage. So how to figure out which is the problem, and it's maybe sometimes it's hard for users to deal with this problem. So I think in this scenario, they tend to use the separated servers for the storage use and the computer use. Another reason is that, as you know, for telecom applications, most of traditionally the application is running on the box devices. So that means the telecom customers is familiar with the pattern that they will use some devices is dedicated for one functions, for example, the computing or the storage. So if the servers involved so many functions, for example, the control, storage, or computing, maybe it's complex for their use. So for our operation team, they like the mode, the separated mode.
Yes, this is Ziqiang from China Mobile. I'm also from China Mobile. We also have our server and hardware team. Yeah, they will define the server for computing, and they will define the server for storage. And the OpenStack team will input the requirement, and then we bought the servers each year with computer mode and storage mode. Yeah, thank you.
I see. That's really interesting. Cool. So it sounds like it's mostly because of the scale. It doesn't make sense to do hyperconverged. So it's very much just different system profiles,
yes.
and you have compute and storage servers.
Yes.
Cool. Well, while we have you here, I guess then we can move on to the next subject, which is kind of dynamic inventory management. And so I think we have some comments already there from someone at China Mobile who wanted to share their tool to does the hardware inspection and the automation procedures when hardware physically arrives. So I don't know if you can maybe unmute and share that a little bit with us to start the subject.
Hello, Mohammed.
Hello.
Yes, my Han will give you some introduction about our automation solutions. Hello, Han.
Cool.
Yeah, hello, everyone. Hello, Mohammed. I'd like share the automation procedure for China Mobile hardware arriving the data center. We have the automation for hardware inspection. First, after hardware placed on racks, we will scan serial number label and get the relationship mapping between devices and cabinet physical position. Second step, we'll do the cabling and automatic configuration for switches, which is the network base for servers automation. Third step in automatic server configuration and check. We have two solutions, centralized mode and distributed mode. In the distributed mode, first, a dedicated VLAN for PXE boot is prepared in all UR2R switches or management network plane. AutoTool as a PXE server will push a PXE image running in RAM to all the target servers once they become power on or reboot. When agents inside the PXE image, when the target server boot up, the agent will be running status, which will communicate to the audio server and upload all the concerned device information to Auto. Actually, the large scale servers auto-check task is distributed to all the agents running in the different servers. So when server's number increase a lot, auto-check consumption time almost doesn't increase. In one resource pool of China Mobile, Network Cloud, there are about 1,500 rack servers. One round of servers auto-check takes 1.5 hours. In this mode, besides auto-check, Auto2 can also auto-config IP address and host name of all servers' BMC ports and enable all network cards LLDP setting according to the low-level design data, including all server serial number. In centralized mode, Auto2 will assign IP address to server BMC port by DHCP. Auto2 in centralized mode will on its own acquire and collect all target servers information through unified Redface interface, which is defined in the specification. The workload on Auto2 is higher compared to that of distributed mode. When server number increase, the auto check consumption time will increase linearly. But the advantage of a centralized mode is the requirement to network is simple and doesn't interfere server's OS. This mode is applicable to small-scale servers to auto-check and resource pool carry service expansion scenarios. Okay, that's my content to share. Thank you.
That's very interesting. So I would appreciate if you can also share that on the Etherpad so we can have a log of that information in the notes, because I think that's really interesting to discuss that. So that's really interesting to hear a story kind of from, I guess, introspection and automation at a very high scale, especially in the scale of China Mobile. But I'd like to maybe wonder if John, maybe you can share a little bit about how, I guess, KOB's, inspection and dynamic inventory management works out, just to kind of share the different stories of how it's possible.
Yeah, I can share some stories from KOB land. I think Mark's here as well. He can share some interesting stories as well. This is one particular project that we're sort of currently working on. So it's just over 10 racks of machines, I think, we're trying to onboard all at one time. But yeah, it's a kind of similar approach to similar kind of approach in that there's a handheld scanner that determines like which machines have got in which rack. That gets cross-referenced to the details that we get from the vendor about what they've actually shipped into the data center, so you know that those two things match up. And effectively, KB it's making use of Ironic an Ironic inspector to do various bits and pieces. So one particular mode we're trying is actually we guarantee that these machines came with the out-of-band management doing DHCP, in this case iDRAC. And then what we were able to do is basically you configure the switch so that iDRAC, its packets are going onto a tagged VLAN inside the network. That what we actually did is we actually used dangling neutron ports. I'm not sure whether this is meant to be a feature or not. If you have an unplugged neutron port, Neutron DHCP is quite happy to hand out all of the information, which was convenient. So basically we're using Neutron to drive the IPAM. So we just had a little Terraform script that takes the CSV and creates neutron ports. So that handed out all the IPs that are now known to the out-of-band management interfaces. And then that was then all enrolled into Ironic. And really what I wanted to do is to make sure that Ironic could do all the state management. So it's already got state management for all the different stages of onboarding as far as I'm concerned. The only extra thing we added was we actually used the extra information in Ironic to just say which bit of the onboarding process we got to, just to make sure that the scripts that were running through could say, oh, I've done X, so I can move on to Y. For this particular case, the tricky thing we had is that these are, I kind of mentioned it a bit yesterday, they shipped with Mellanox NICs that we had to flash and then turn into Ethernet mode in order to be able to do the LLDP on. So you kind of wanted to get the point where you've done the firmware flashing of that. So it turns out, yeah, we could, once you got the system into Ironic, we're able to use out-of-band inspection to discover the MAC address, to then do the neutron port trick again to hand out RAM disk booting. So basically we booted into the inspector RAM disk, but this wasn't actually the inspection network, it's the outbound management network. You could probably just use inspector, but anyway, that meant that you could determine the MAC addresses, the known ones, and do that. But yeah, there's a lot of scripting on that, but it had a lot of the hooks to help through that process. And obviously using inspector rules to try and classify the nodes. So in this nodes, as you know, you've got high mem nodes versus low mem nodes within the cluster. And we can use the inspector rules to just sort of kind of add the appropriate resource class into Ironic as required. So effectively try and feed that inspector JSON file into through the rules to do the right thing.
It's really interesting. So I looked at the repository with the inspector plugins that you have. Those are really neat, and I guess we should probably, it'd probably be nice to upstream those as well.
Yeah, that makes sense. If they're useful to other people, for sure.
I think at least one of them has been upstreamed. Harold Jensis was putting together a similar plugin. So I think we grabbed the kind of the base class from this, and then which one was it? I think it was the system name FizzNet one. Anyway, if there are others that are useful, we can upstream those as well.
Yeah, I know for a fact the InfiniBand one, especially getting the physical network, is one that like we were starting to write. So now that I see this, I'm like, well, this is nice and useful. Should probably work on this together then. Cool. I think those are two kind of ways of like inspecting. That covers a little bit of what and how Ironic also does it when we talk about KOB, because it kind of indirectly uses the same kind of idea or platform. I know Jaden talked a little bit about the hardware challenges that's preventing them from automating system onboarding, more specifically about VLANs to manage networks and PMCs not supporting tag traffic. So, you know, can you maybe expand a little bit on that?
Oh, sure. So since in our environment, we're going to be running multiple separate distinct clouds using the configuration I discussed earlier. So we wanted to be able to isolate those clouds and isolate the hardware management system from those clouds so that a user can't accidentally or intentionally make changes, because we recognize that IPMI has a lot of vulnerabilities historically. It hasn't had a good time. So we wanted to try to do things to secure our network in different ways, but we found that some of our BMCs don't support using VLANs or tag traffic or things like that at the hardware level. So that made it difficult for us to manage the networks in the way that we would like. So we've had to come up with some workarounds, like using ACLs in our switches and controlling like where the traffic can flow, physically segregating different parts of our network. So like only certain specific machines are connected to certain, like we have a separate network or separate physical switches for our IPMI interface to try to isolate further there. And then, like I said too, we just had trouble, like Ironic has good Redfish support, it looks like we haven't any problems with it, but whenever we try to do specific things with some of our servers, you know, what might work on one server doesn't work on the other server. Just because the vendors, maybe they didn't do Redfish all the way yet, or like they prioritize certain pieces over other pieces, or they just have their particular dialect of Redfish, even though it's a standard, it just is different for that particular machine type. But yeah, those are some of the issues that we've had. I would say otherwise, Bifrost and Ironic and the work OpenStack has been doing has been great for us for automating and moving forward with the hardware automation.
That's good and interesting to hear. Has anyone had similar struggles with hardware as some of the ones that were just shared? No, I certainly know that. Yeah, go ahead.
Redfish is definitely one. I think that's partially why we have a whole topic for it in the second half of this morning. So after the break, we'll end up talking about Redfish, and I think we'll get into some of those issues and some of those headaches and pain points, and hopefully find things to fix or work on.
If we want to shift gears, I will say, I forgot to write down, but we did have some trouble with getting the images built well, like disk images or operating system images built in such a way that Ironic can use them. At some of the tools, like I know we had some issues going to CentOS 8, like trying to use a CentOS 8 disk image using like Disk Image Builder or some of the other tools that KOB and Ironic recommends. I think D King, Daniel King, who's here, can speak more to that for me. Because I know he's done more of that stuff for us than I have.
I think that at the time, I'm sorry, we were using KOB, and I think I was having more trouble with some of the configurations there, accepting it. But yeah, the disk image builder, I think I've got that mostly worked out. I'm trying to remember if there's anything still outstanding with that one, but I know there have been different quirks with using it at times. But for the most part, I think we're pretty solid.
Just while we're on that topic, I suppose I should say I discovered that Disk Image Builder has breakpoints, and after I discovered that, my life was a lot happier. So you can drop into the cheroot at the right moment when it all breaks. So the breakpoint on error, yeah, it stopped me shaking my fist and having quite so much coffee between runs. So I'd recommend it. Just as a heads up in case anyone else misses that.
Is there a document you can link to in the Etherpad to help everyone else?
Yeah, I'll go find the link.
Thank you.
Yeah, that'd be pretty useful for me. I know that I'm having an issue right now with the disk image builder with one of the IPA images that I can't. The dev user is on there, but it won't let me log in with the dev user. Just keeps erroring out, and I can't debug that yet.
That one's always an annoyance. Yeah. Okay. I always tend to set the password, I don't know, in a dev image and shove out a dev image.
Yeah.
The password setting that's not working.
It sounds like we have a bug we should fix.
Maybe. I always get confused about which key gets injected. I think that's my problem. Because I forget which user ran it with what key, and it's never the one I have.
That does bring up a point. I'm using the disk image builder to create a raw image, but then later on I'm using Packer later to update it. Now, for my deploy image, I'm not using Cloud Init, so I'm trying to bake the public key in, but I don't have a way of doing that with disk image builder. I know with disk image builder you can create a dev user and you can set a password on there, so that's something. But it would be nice if there was a way to inject. So some generic credentials, maybe even root credentials, because that'd make it easier. Right now, I'm just using GuestFS tools to modify that image before I then take it into Packer.
I should link to the docs because there's definitely a whole load of options that let you give the dev user sudo and then let you set keys.
Well, I saw that for the dev user. The problem is that for some reason when I was trying to run Packer with QEMU, it was not for some reason accepting the become with the Ansible provisioner. So it was there's probably more issues than just that, but yeah,
I'll give it. Yeah, I think I've got a link to. We were trying to make an experimental way of running Python inside Disk Image Builder, so you didn't have to do everything with shell scripts, or rather, you can share the Python, the Ansible that you're doing post deploy with the run the Ansible inside the Disk Image Builder pipeline. Let me try to look up the link for that. That might avoid you having to use Packer.
And we have a comment also shared that sometimes if SC Linux is around, it causes issues connecting as dev user. So maybe that's related, or an insightful comment that might be helpful. And kind of going back to briefly touching on this is, what about automating offboarding? You know, it's probably not something that's very common, but, you know, is there anything you do in that scope, or is it just delete, get rid of the disks, just ship them off to a company that does destruction and move on with life?
Well, let me, I think for the most part, that's true for us. However, we typically have a bunch of backend systems that have to be pulled out. So we've automated a lot of the removal from the backend systems, but the removal of the images from the box, yeah, you're right. We don't pay a whole lot of attention to it, which we probably should, because they have, you know, customer keys on them and other sensitive data.
Yeah, that's true. Obviously, that needs to be stripped off.
Yeah, I know one organization that's at least contributed a bunch of logic to help support tearing down machines and retiring machines was CERN, actually. So what they do is they actually, hopefully someone from CERN can take over here with this, but my understanding is they set a retired flag, and when the machine's deleted, it goes through the entire cleaning process, and then at that point it doesn't get rescheduled, it can't be rescheduled, and they can just basically unenroll the machine at that point, and it's ready to go repurpose, or, you know, I don't know, sell on eBay to recover some of the expense of the original machine. I don't know what they're actually doing at that point, but
Yeah, but that won't impact the images. Since they're in the repository, they're not on the machine itself.
I'm a little confused because
that sounds about right, Julia, from what I understand. In fact, the machines at the end are often given to collaborating labs in countries around the world, like Lithuania and Morocco. So we do things like reset the IPMI credentials as well to be really sure that we're not leaking anything.
And the reset or the retire flag was mostly added in order to like ease the handover between the different teams. So like the Ironic team managing the physical nodes and the team that's actually preparing machines for donation to like ease the handover, we introduced this retirement flag that could be set at any moment. And then the moment the instance gets deleted, the retirement flag actually allows the machine to still be clean. So like as Tim said, like erase the credentials, erase the disk, do another burn-in, because we usually like test that the machines are like, they go through the same burn-in basically and the same testing as we get them initially. So before we donate them, we make sure that they're absolutely working fine. And this is why we had this retirement, because Ironic didn't have that mechanism to actually allow cleaning after you mark the node for being retired. So this is what this retirement flag is for.
That's really interesting.
That's very interesting. So if we have a command to kind of restore the node to the initial or pristine state, would that be helpful? Or it doesn't really matter?
Well, this is basically what cleaning is supposed to do, right?
Yeah, but cleaning does not return it to the original state. Cleaning will remove some of the stuff, but doesn't mean it will return the configuration to initial state, including RAID and stuff, other stuff like that. It will do some cleaning, but it will not return to the
Yeah, I think our
original
case thoughts
state.
is like the machine is not going to come with like root Calvin username password and like the OEM shipped defaults.
No, but the like initial state is like the disks are completely erased. There's nothing on the disks, right? And the like BMC credentials are reset to some random things. So this is what cleaning is supposed to do.
So I think that there's an important delineation that needs to be made. With Ironic, you have hardware managers, and these hardware managers can be dynamic. And sites like CERN do have additional hardware managers that they use. So you're able to actually, depending on what the hardware actually boots up and sees, take additional actions or additional processes, so they could actually, their hardware manager could actually see, oh, I'm retiring, I need to do a bunch of extra work now.
Right. This is actually what we do. Like, for instance, for the RAID configuration, what we do is, like, rather than making this manual cleaning step, we added this to our downstream hardware manager. So the moment you clean a node, it actually checks the RAID configuration that is configured and resets the RAID configuration to that specific state. But this is all, like, you have to have, as Julia said, you have to have your own hardware manager where you, like, instructed what to do.
It's a really interesting conversation on this subject, and we got like 7 minutes before our break. We kind of have one more topic, and I feel like this last topic is one of those kind of really interesting in theory. I don't know if anyone is doing it yet, so we'll get a chance to kind of all sit and imagine what would be an ideal world to do this. And so this is one of those ideas of changing bare metal machine roles kind of on the fly, and the ability of maybe having one machine that's being used as bare metal, and then if you need extra virtual machine capacity, you provision that as a hypervisor and connect it to OpenStack and use it as such. And then if you need more bare metal capacity, you unprovision those machines and provision them back as bare metal. So kind of like a back and forth system that allows you to have a pool of hardware that could be either computes or bare metal machines. And I know Julia seemed excited to see me bring this up. I want to hear thoughts about that.
Well, my dream would be that we build our data center such that when we don't need a bunch of spare capacity running, that we start shutting down or idling or even somehow suspending the physical machines, so that we reduce that power capacity, we reduce the cooling usage, maybe even make the noise level a little quieter, because, you know, as someone that has some hearing damage, I don't want more going into a data center.
Yeah.
So to me, it's like the ideal thing, and I would love to have some requirements or understand what people feel they need in these kinds of situations, because I think we should be building these applications to be dynamic and elastic and also treat our underlying infrastructure. So the question for me becomes, how do I, or what requirements do I need to meet in like bringing that machine back online as it was, or provisioning the same thing again, or be able to shift machines' roles? What orchestrations needed? How would we approach this? Because you don't really think about these sorts of things often when you're running tens of thousands of machines, but even 1% of your power bill can be a huge savings, a huge amount of savings on wear and tear on equipment.
Yeah.
I mean, then again, you may also increase the cost, the wear and tear on the CPU fans or whatever, but these are the kind of things we need to think about in our society and our environment at this point. I'm sorry, I'm rambling.
Yeah, I think that's really interesting.
This is Rob Hirschfeld. I can talk about what we've built from a pooling capacity and the use cases that we saw from that perspective. Pooling is a delivered feature for us next week. It's a tricky feature.
Is it my internet or is it Rob's internet?
I think it's Rob's internet. Oh.
Yeah, I think it's Rob's internet.
Yeah, Rob, you're cutting in and out.
All right, hold on. I'm gonna have to leave and come back.
Okay, I think I heard, or Katie maybe wanted to comment on something.
No, I was just curious. Do we really have decent data in terms of, you know, bringing power things up and down multiple times? What is the actual wear on the hardware? Is those kind of scenarios? Because most of the time people kind of turn it on and it's running all the time. Yeah, you can reconfigure it once in a while, but you know, powering it up and down is a very different set of the you know, wear and tear on the node.
That's absolutely true, and I've moved data centers and feared what would happen to the physical disks. Would they actually start spinning back up at all?
I will show my age and talk about the old quantum discs that would, if you ran them for a long time and you stopped them, the lubrication for the bearings would freeze, and you had to whack them on their side to get them going again.
That's awesome.
Wow.
On that note, at least now these days, SSDs, I don't know if anyone has any of the Intel one, like 2 terabyte SSDs that had the lovely firmware bug of spontaneously combusting after like 1800 hours of runtime. Like they literally just die, and there's a firmware update for that. So yeah, guess who learned about that? Yeah, I did. So that's one of the interesting ones. I see Rob is back. Maybe want to hear some of the.
Yeah, can you hear me better now?
Yeah.
Much.
Oh, sorry about that. When I move around, it jumps hotspot or jumps Wi-Fi zones. Yeah, so this is a delivered feature for us in the upcoming release, and it's tricky. And the use cases you're describing, one of the challenges of doing that is the reliability of the backend system. Oh boy, I'm trying to think of the right place to start because I want to be use case focused in the description. So the use case you're describing seems pretty straightforward from a resource pool. It gets tricky quickly because then you start getting things like we talked about yesterday, where is there zones or machine specific information that has to be considered in the allocation request, because it falls apart if you're asking for a machine or for a specific machine. It requires you to say, I need a machine from this resource pool, usually matching this criteria. But then the thing that makes it this untractable for a lot of use cases that I've seen is that if it's not incredibly reliable, then people won't trust it to do the nightly migration. So it's the dropout rate is just as much of a problem. And so one of the things that when we built the feature, we were incredibly careful with was transparency in the operation. So for us, because of the workflow integrations for Rebar, what basically is happening is you're getting a machine, you're getting and it starts a workflow for you. Those two operations together are the requirement. Is not as simple as just giving me a machine. It's giving me a machine and start this workflow. And then that translated into parameters and profiles that you have to set, because you then have to influence a whole bunch of information pushed through that process. And then if something doesn't work correctly, you have to have a state machine behind the scenes that's going to decide to hold, wait until the system's done provisioning. When it is done provisioning, hand off to other links. So the state machine behind this actually got pretty tricky from that perspective. It's the thing that's nice is that at the end of the day on that lets you drive like Terraform. So you can take Terraform and create a provider, or say a cluster API and do a provider. Those systems tend to require this. The other use case that we see for this is not dynamically shifting workloads, but being able to actually use other cloud-based tools for hardware. Ends up being pretty straightforward on the APIs, right?
That's interesting because it sounds like a lot of things you've experienced needing. It sounds like most of it we already have, at least in the OpenStack community. We're probably just missing some of those edge interactions and requirements, but we're also kind of over time.
My expectation for the OpenStack community is that those use cases will be fulfilled by using Ironic under OpenStack as letting OpenStack be the API provisioner. And so from that perspective, you have a resource pooling utility built in. Not built in is the problem. But there's a lot of overhead from that perspective to make it let go.
Okay. Okay, that's really interesting. So I want us to put a small pause on this discussion because actually I think this topic leads on really well for the topic that we're going to be discussing after the break, which is talking about preemptible instances, which really is also another way of reusing bare metal. And you know, it's a similar use case. So I think we're going to be going on break until, and we're going to come back in 7 minutes, if I'm correct.
You are correct. Yes.
Perfect.
We'll see everybody at 14:40. So yeah, in about 7 minutes. So enjoy your quick break and we'll see y'all in a bit.